Hi students, MCQ number 7. A gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. Neglecting all the vibrational modes, the total internal energy of the system has to be determined. Okay, now the total internal energy of the gas mixture is given by what expression? It is given by U is equal to number of moles multiplied by CV, molar specific heat capacity at constant volume, into the change in temperature. So this is the expression I am going to use. Now out of the two given gases, one is oxygen, which is diatomic, and the other one is what? Argon. Argon is monoatomic. So I will write for oxygen first, okay? For oxygen O2, the number of moles N1 is equal to what? 2 moles, okay? So N1 is equal to 2, and the value of CV for oxygen diatomic gas is 5 by 2 R, okay? 5 by 2 R. Like this, for argon I am going to write now, okay? For argon we write like AR only, is it not? Because it is a monoatomic gas. So the number of moles N2, here it is given as 4 moles. So N2 is equal to 4. And for monoatomic gas, the value of CV is equal to what? 3 by 2 R. Okay. So this equation I will write U1 for oxygen and U2 for argon, and I am going to add. Okay. So U is now equal to N1 into, instead of CV, 5 by 2 R for oxygen. So 5 by 2 R into the temperature is T. So this is for oxygen, okay? Plus number of moles N2 into CV for argon is 3 by 2 into R, and the temperature is T. Now N1 is equal to 2. So this is equal to 2 into 5 RT, okay? So 5 by 2 RT plus N2 is 4 into 3 RT by 2. So now if you take, so this is 2 and 2 get cancelled, 4 and 2 get cancelled twice. So remaining is what? 5 RT plus 3 2s are 6 RT. So that this is equal to what? 11 R into T. Okay. Therefore, U is equal to what? 11 RT. This is the total internal kinetic energy of the, internal energy of the system. So which must be the correct answer? You see here, 11 RT. Option D must be the correct answer. Okay. Therefore, option D is the correct answer. I hope you must have understood well. Fine.